is where we continue from where we have left off. In a previous exercise, we have learned how to pre-process the dataset and make some visualization for that. And also we have done a correlation with the also some visualization. Now let's do a linear regression. So we're gonna start with importing the libraries that we're gonna use in this exercise. So import NumPy as a NP, import pandas as a NP or BD, sorry, and from sklearn have model selection. We will import train underscore test underscore split, and from sklearn we will have a linear model, linear underscore model will be importing, import linear regression. And finally, we want to assess these models. So from sklearn dot metrics, we will import mean underscore squared underscore error and R2 score. And now after doing that, let's import our data sets here. So df will equals bd dot read underscore the CSV file, and you will find that we have already a filtered data. So this is going to be petrol underscore consumption dot CSV file. So this data doesn't need any pre-processing. You can check out. So you can see if we have a df dot is null, and we can add summarization for that sum. And you can see that there is no any missing data set, which is make it ready for multiple linear regression. Now let's define our x and y. So x will be equals our data frame dot. We're gonna drop only the target in this time. Of course, you can like after filtration and pre-processing can drop more than that if there is any useless data. So we're gonna drop from the columns equals this data here. So this is gonna take it here to make sure I'm not making any typos. And now we can destinate y. So y will equals df, and then open a square bracket, and this is going to be your y. Now you can use the split function. So x train, x test, and y train, and y test will equals the train underscore test underscore split for x and y. And now we're gonna have the test underscore size equals, let's make it 0.3 this time because we need a good data number of data set for the testing. Now we will have the random state equals to 1, 2, 3. After doing that, so we're ready to fit the model. So we have the model equals linear regression and open close banana bracket. After that, we're gonna fit the model on our trained X and Y. So it's model dot fit. We have the X train and Y train. After fitting the data, we want to assess our regression model. So we can start having the Y prediction. So Y predict equals model dot predict for X tests. After that, you can determine the mean square error. So mean square error equals mean underscore squared underscore error for the Y test and Y predict. And you can do the same thing for R squared. So you can here just to print it. So print MSE. And then we determine R2. So R2 equals R2 underscore score between Y predict and Y test. And we want to print it out. So print R2. Let's run the function. Okay. So this is like the space. So this is mean square error, and this is the R squared. So our model wasn't that great, I guess. Maybe if we can increase the training data set a little bit, let's see how it goes. So we have an overfitting problem, as I mentioned to you in the class here. How about 50-50 splits? So still we have some problems here, maybe with the other folds. Mm, Interesting. Let's see how the data look like visualization. So let's plot plt dot figure. We have the fig size equals, let's make it 10 by 10. And we want to have plt dot scatter. So between uh, so let's do it between the Y tests and Y predicts. And we want to show it. So plt dot show and see what's going on with this thing here. Okay, so we haven't import this library. So import matplotlib dot py plot as a plt. So we can see they are not within a line. So there is like the linear regression is not the optimal one, but at least we get the idea.